Hello pre-calc students and welcome back. Today we are continuing section 5.1, verifying trig identities. The homework assignment for tonight is the same as the homework assignment you got Thursday. So on Thursday we said that you were doing night 1 of this assignment. So tonight will be night 2, which means you need to, at the very least, attempt every problem. Finish all those that you can, and then come with questions on those you were not able to finish tomorrow. You need to be able to show me that you've tried every problem, and tomorrow in class I will be asking you to show me your work. That is something I will be checking, so make sure that you have at least attempted every one of these problems. Today in this video I've got a few more examples to go over, and it doesn't get into a little more advanced strategies than the ones we went over last week, so you'll want to check these examples out. Please keep in mind we will be using these identities throughout, so make sure that you've got them written down somewhere or you're looking at page 622 in your textbook. So here are the strategies we talked about last week. We've looked at many of these, and today we're going to try a few more of these as we do some of these problems. So here's the first example we're going to look at. Now, as we're going through these, if you ever want to pause the video, try some of it on your own. I think that is a great idea. Let's take a look at what we're going to do to solve this one. For this problem, our hint or our strategy that we're going to use is we're going to combine these fractions over here on the left side by using a least common denominator. So here's what that looks like. You can see that here are my two different denominators. So my least common denominator needs to have this factor and it needs to have this factor. So I'm going to multiply the left fraction by cosine x on top and bottom, and I'm going to multiply the right fraction by 1 plus sine x on top and bottom. When I do that on the top right here, I get cosine times cosine, which is cosine squared. Here I need to FOIL these two binomials, and I get 1 times 1. Sin x times 1 plus sin x times 1 is 2 sin x, and then plus sin x times sin x is sine squared. On the bottom, I'm actually not going to distribute because I actually want the bottom factored later, so I'm just going to leave it like so. Now that I have common denominators, I'm going to add the numerators. So now I've combined them into one fraction, and I get cosine squared x plus, and then all that, 1 plus 2 sin x plus sine squared x. You'll notice, though, I do have one of my favorite Pythagorean identities hidden here on the top with some stuff in the middle. I've got a cosine squared x over here, and I've got a plus sine squared x over here. And if you think about those two together, we know from our Pythagorean identity right here that that is actually equal to 1, which means I can replace those two with a 1. Now, don't cross them out. They are equal to 1, not 0. So make sure you replace them with a 1, and then I still have this plus 1 right here, and then I still have a plus 2 sine x. At this point, I can combine like terms at the top, and 1 plus 1 gives me a 2 there. And then on top, I've got 2 plus 2 sine x, and then I'm going to find this greatest common factor of 2, factor out that GCF of a 2, and I get 2 times 1 plus sine x on top, and on the bottom, I've got cosine x times 1 plus sine x. And you can see that I have a common factor on top and bottom of 1 plus sine x. I can cancel those, they become 1, and I'm left with 2 over cosine x on the left side of my equation. And now you can see that this is getting really similar to this. Basically, the way I think about 2 over cosine x is 2 times 1 over cosine x because 1 over cosine x is equal to secant x. And now you can see here I am done. 2 secant x is equal to 2 secant x. And then moving on to example number 2. So again, if you want to pause this, try it a little bit for yourself. First, I'd recommend that. So I'm going to jump right in and use this strategy. I'm going to multiply by the same thing on top and bottom, which this strategy is a little bit weird at first. You might be wondering why I'm going to do this, but you'll see what happens here in a second. So what I'm going to do is I'm going to take this fraction on the left and I'm going to multiply it by the conjugate of the denominator. And if you remember conjugates, here I've got a 1 plus cosine x. I'm going to multiply it by 1 minus cosine x, and then I'm going to do the same thing to the top. And I'm going to leave the right side of the equation alone. So you can see what happens here when I do this, and here's the reason that I do this, and this just takes practice to recognize when this will happen. You just need to try a lot of problems so you can see this, is that I don't get a middle term because cosine x times 1 and then negative cosine x times 1 will add up to 0, and I'll just get a 1 minus cosine squared x. And if you remember back to last week, that was that special secret form of our favorite Pythagorean identity where the cosine squared is moved over to the other side. And if you remember what we talked about there, that means that 1 minus cosine squared x is actually equal to sine squared x. So there on the bottom of that, I can replace this part with a sine squared x. And now I've got a common factor on top and bottom. I've got a sine x over a sine squared, so I can cancel that one sine x there with one of those sine x's, and then you can see that all of a sudden I've got the exact same thing on the left and right, and I'm done. And then moving on to example number 3. You can see this one has one thing that's new. You can see that in this problem here, I've got these angles called x, here, here, and here. But there's one spot here where I've got an angle that's actually the opposite of x. So what I want to do first is deal with that, because I want my trig identity to always have the same angle, and this isn't the same angle as these other three. So if you go back to our identities, you can see that we had a whole category of identities that dealt with this, called the opposite angle identities. And I'm going to use this one right here because it's the sine of a negative angle. So what I'm going to do is I'm going to replace that sine of negative theta with a negative sine theta. And here's what that looks like. So I take this sine of negative x and I replace it with a negative sine x, which you can see I've changed from minus a negative to adding a positive. And now I've got the same angle in all four of my trig functions in the problem. At this point, I'm going to simplify the left side, and I'm going to rewrite my tangent using sine and cosine. So this tangent becomes a sine over cosine. But that's just the top of my fraction. On the bottom, I still have 1 plus cosine x. Now you can see I've got a fraction inside a big fraction. And the way we deal with that is we multiply through by the common denominator, both on top and on the bottom. So I'm going to multiply everything on top by cosine x, and I multiply everything on bottom by cosine x. When I do that, I get the following. So on top, I get a cosine times that sine over cosine to get cosine x sine x over cosine x. And that's cosine x times sine x. On the bottom, cosine times cosine, cosine times 1 plus cosine times cosine gives me that. And the whole reason that I did that is so that I can cancel these two cosine x's, so I'm left with no more fractions in my big fraction. Now at this step, you can see what I've done here is you need to identify your greatest common factor. So in the numerator, I've got a common factor of a sine x, because I've got a sine x in both of those terms. So I factor out a sine x on top. On the bottom, though, I have a common factor of cosine x. So I factor out a cosine x on the bottom. Now when I factor out a sine x from the top, I'm left with sine x times 1 plus cosine x. When I factor out a cosine x on the bottom, I'm left with cosine x times 1 plus cosine x. And you can see there, I've got a common factor of 1 plus cosine x on top and bottom. I can cancel those. And now I've just got sine x over cosine x equals tangent, which, yes, it does equals tangent. So my final step is to write tan x equals tan x. And there it is. And here we are with our final example. For this one, you'll notice I don't have a hint this time, and I think it would be a good idea for you to pause the video here in a second and try it on your own. The suggestion I'll give is you're going to want to simplify both the left and right sides. So, I don't know, take a few minutes, give it a try, and then press play. So, what I'm going to do here is I'm going to start by simplifying the right side. So, first thing I'm going to do is factor out this common factor of 2. So I factor out a 2 and I get the following. And then you'll notice that 1 plus cotangent squared is one of our lesser known identities. It's not the famous one, but it is another one of our trig identities. 1 plus cotangent squared theta is equal to cosecant squared theta. So that 1 plus cotangent squared theta is going to become a cosecant squared theta. So now I've simplified the right side, and now I'm going to go over here and work on the left side. I've got two fractions with two different denominators. So what I'm going to do is I'm going to make common denominators so I can add them together. Now this 1 plus cosine theta, this fraction needs a 1 minus cosine theta, so I multiply the top and bottom by 1 minus cosine theta. The right one needs a 1 plus cosine theta, so again, multiply top and bottom by 1 plus cosine theta. So on the top, I just get 1 minus cosine theta there, 1 plus cosine theta there. You'll notice these that I'm multiplying by happen to be conjugates. So when I multiply them together, I FOIL. However, the two middle terms will add up to 0, and I'll just be left with 1 minus cosine squared for both of my denominators. Now that I have common denominators, I can add those fractions together. So I add the tops. And I get that. Now you can see that I've got a 1 plus 1 there, and then I've got a minus cosine theta and a plus cosine theta. So when I simplify the top, 1 plus 1 is 2, and then minus cosine theta plus cosine theta is 0, so I just am left with 2. Then I hope you're starting to recognize our favorite Pythagorean identity in disguise here. 1 minus cosine squared theta is indeed equal to sine squared theta. And now at this point, you should hopefully be able to see that, hey, 1 over sine squared is equal to cosecant squared. So basically, you can just think about this as a 2 times 1 over sine squared theta, so that you can write it as 2 times cosecant theta. And if you want to skip this step right here, I'm fine with that. You can go straight from this step right here down to this one here. But now you can see that both of our sides are 2 times cosecant squared theta, and that's it. So that was the last example that I've got for my video today, so make sure you attempt every problem in that homework assignment, and I will be checking that tomorrow. Have a good day.